A new drug for stroke prevention, CLOTBUST, was studied. The trial enrolled 2,546 patients. In the CLOTBUST arm, 39 out of 1,281 patients had a stroke, compared with 64 patients out of 1,265 patients in the aspirin arm. P-value equals 0.025. What is the number needed to treat to prevent one stroke in this trial? So the key question, number needed to treat. So number needed to treat is also abbreviated NNT. And number needed to treat is equal to 1 divided by ARR, which is the absolute risk reduction. Since this is not given in the question, you get to know the definition of absolute risk reduction, which is the CER minus the EER. So this CER is the control event rate, and EER is the experimental event rate. And so you have to find what this is in the question. So the CER is the same thing as this, control event rate, 64 out of 1,265 patients. So this is the control event rate, 64 over 1,265. And then subtract that by the experimental event rate, which is here, 39 out of 1,281. So these are always decimal places. And if you don't know which one's to which, it doesn't matter because your number needed to treat is not going to be a negative answer. So if you had accidentally switched these two numbers, you just get your final answer is going to be negative. And obviously, the number needed to treat is like the number of people that you need to treat. It can't be a negative number. So that's why you know it's going to be like this. So just take the bigger number, decimal minus the smaller decimal. And so when you solve for this, remember you're gonna have like a really crappy calculator, so you just have to type in 64 over 1265 in your calculator, and that would be 0.05059289. That's this here. Subtract that by 39 over 1281. That equals 0.030444496. And so I'm going to do this calculation, the subtraction in the calculator, because you have a really crappy calculator. So 0.05059289 minus 0.030444496. That equals 0.020147993. Right, so this is easier to put in your very basic calculator. So 1 divided by this number is equal to 49.6328903. Keep as many decimal places as possible until your final answer. That's why I have so many decimal places here. So this is actually a final answer, but number needed to treat is always a whole number, so you always round up for a number needed to treat. So this 49.6328903 is rounded up to 50. And 50 is what you enter in the computer. So in the Naplex, it's always going to be, they're always going to give you like a number decimal place that's 0.5 or higher, so you could easily round up. But in real life, it doesn't matter what the decimal place is. If it's 49.1, it's still rounded up to 50. Because number needed to treat is like a conservative answer that you want to treat, the number of people you need to treat to get a good statistical data. So that's why any number is always going to be rounded up no matter what. It's not rounded down. It's not like conventional rounding up. So whatever number you have, see all these numbers, decimal places, they all will be rounded up to 50 as for number needed to treat. But in the Naplex, they're going to make it easy. I guarantee it's going to be a number that's higher than it's 0.5 or higher, because it makes it easy for the whoever's taking the test. So always remember to round up. So that's why the answer is 50 in this question. So if you have any questions, please leave it in the comments. Thank you.